I want to tell a short story on melanocytes and pigmentation, where the melanocytes come from, and why there's variability in the human population. And then we'll talk a little bit about appendages, because when you think about skin, there's a modification of keratinocytes. The story that we learned last time about the organization of the dermis and the epidermis will be the same. But what we'll do in the case of hair and nails, hooves in particular, is we're simply going to change the type of keratinocyte. And that will change the type of keratin in those cells. And we'll talk a little bit about how that comes about, but the story here is identical to what we talked about with skin. Then we're going to start this topic of bone structure. And bone structure will run through fairly quickly. We're going to think now of bones as an organ. There are going to be multiple tissue types in bone. Bone is one of these things we think about all the time because it supports our bodies, it allows us to move, and it's a really important part of our lives. But we're going to bring this down simply to the long bones and long bone structure and use the long bone as the archetypic bone. If you take an anatomy course, you're going to learn a whole lot more about different kinds of bones, different shapes of bones, where muscles attach, and all that. But today, I simply want to go over the structure of bone and how they more or less work at a cellular level. We'll see that when we look at a bone and we open it up and we look at the types of bone, we see two general types of bone. We see spongy bone and compact bone. The rules are pretty much the same for these, but in fact, spongy bone and compact bone look a little bit different in their organization. The spongy bone is going to look like a series of struts or spicules, and although the organization of those struts will appear random at first glance, turns out that these are the organization orientation is best produced by the way weight is distributed. And what I mean by that is there's a certain amount of plasticity, malleability in the spongy bone that will change the shape of this bone as we change the way we distribute weight. But that's also true for compact bone. And I want to tell the story mostly through the point of view of compact bone because it will give us some generalized ideas about how compact bone is organized and why it functions the way it does. Again, we're going to see that the osteocytes are a classic connective tissue cell type. They secrete extracellular proteins. One of the major proteins that the osteocytes are going to secrete is going to be collagen. In addition to the collagen, though, they're going to secrete something known as hydroxyapatite, which is basically calcium phosphate. And we talked a little bit about this last time. And we'll see here, then, is that these two molecules have slightly different functions. The hydroxyapatite, like marble in a column in the Parthenon, is very, very good for compression strength. You can put a tremendous amount of weight on hydroxyapatite. The problem with hydroxyapatite is it's a crystal. And if you get the wrong shear forces exerted on that crystal, the crystal will fracture. So the way we solve this problem is we run collagen filaments through the hydroxyapatite. And that gives us a combination of resistance to compression forces along with resistance to shear forces. But there are a couple of ideas that we really have to home in on in talking about bone growth and bone remodeling. We all know we grow. We all know that we're born at one size and we finish growing some number of years later. Much of the growth, and the growth story I'll tell you is just in the long bones, but in fact you have growth plates in all of your bones. And the way bone growth occurs is that there are special regions called growth plates. And the cell type in the growth plates are the chondrocytes. And the chondrocytes will divide, and by dividing, they will push outward and allow for bone growth. And then when women reach the age of about 18 and men maybe as old as 20 or 21, then those chondrocytes die and they're replaced by bone. And that's called growth plate closure. And at that point you're done growing. You can perhaps add some appositional growth. You can make the bones wider, but you can't make them longer because the cells responsible for bone growth and lengthening of the bones are in fact gone. But that still opens the interesting question of bone remodeling because, in fact, if you start weightlifting, if you start bearing more weight, you'll actually increase the size of the bones. And it turns out that throughout our lives, we are building bone and tearing it down. And there are two major cell types that are playing this role. There are the osteoclasts. These are known as the bone breakers. They're basically these specialized cells that are releasing acid. They're releasing hydrogen ions. And when they release the hydrogen ions and reduce the local pH, what happens is the low pH will literally solubilize the calcium phosphate in bone, convert that mineral calcium phosphate into calcium ions and phosphate ions, and thereby mobilize calcium ions. This is an important function of bone. We always think of bone as being this rock-hard substance. But in fact, we can move calcium in and out of bone at will. And this is an important idea because we need to maintain blood calcium levels at a fairly narrow range. If they get outside that range, we're in serious trouble. And so there are these hormones called the parathyroid hormone that's important in regulating blood calcium levels, and they play a really important role in mobilizing calcium out of bone. So we'll work our way through that, and one of the final ideas I'll leave you with is that as we grow older, there appears to be an imbalance in the system. This is particularly true in women. So postmenopausal women tend to have excess activity in the osteoclasts over the osteocytes or osteoblasts. So there tends to be a hollowing out of the bone. We think this has something to do with loss of estrogens, but there's a lot of argument about that. But nonetheless, we find that the osteoclasts, if they are the overactive cell type, will in fact make the bones brittle. They'll actually make the bones have holes in them, and that's called osteoporosis. And that's when the osteoclasts outstrip the activity of the osteocytes.